I think we can probably go ahead and get started here. So first of all, welcome everybody, and good morning. This is or good afternoon, depending on where in the world you are. This is our webinar together with WireMock and Lunar.dev, talking about API consumption challenges from development to production. We're going to be talking about basically what it takes to bring an API from a simple integration into a live production product. With me today, we have both Eyal and Uri from Lunar and WireMock, respectively. So guys, first of all, welcome and thank you for joining us for this event. I'd love for you to maybe introduce yourself briefly before we dive into the topics at hand. And Eyal, I'll let you get started.
Thank you for volunteering me. I was going with Uri. All right. So hi, everyone. I'm Eyal, CEO and co-founder of Lunar.dev. And at Lunar.dev, basically, we're an API consumption management platform. Basically, what the product is a self-hosted infrastructure that gives you the ability of having full visibility to all of the third-party APIs that you're making within your production environment, and then actively managing them, helping you to optimize your traffic and consumption by enforcing policies such as API caching, client-side rate limiting, queuing by priority, and such. This is really us in a nutshell, and I believe we'll share more as we go with the webinar. And thank you for having me.
Thanks, Eyal. Thank you everyone for joining. A bit about myself before talking about the company. So my background is in engineering. I was engineering manager for quite a few years. Then I moved to product management, then moved to sales. So did kind of different positions across the spectrum of sales and marketing, engineering and product. And around 3 years ago, I founded WireMock with Tom, with my partner. Tom was already working on the open source for WireMock for quite a few years. And what we do, and we'll talk about it later in a bit more details, is optimize developer productivity in an API-dependent environment, meaning in an environment where a developer and testing team consume a lot of APIs. And the reason why we did this webinar today with Lunar.dev is that we see a lot of alignment on the story of the challenges in an environment where development and testing team are consuming a lot of APIs from development to production.
So I guess with that, I mean, I was always told that there are no stupid questions, but maybe I'll start with one. I was, building a little side project yesterday. I needed to use an API. They had great documentation. I copied a line of code, put it into my Next.js application, and it worked. And I think for me, that was that. Is there more to integrating APIs than that? Because I'm not sure I always realize what the what the extra challenges are beyond just, you call an API and it works. And don't worry, maybe I'll let you get started with that one.
Yeah. So I will start with the dev and test part, and then Eyal can talk about the production aspect. So yeah, like when you are developing maybe a simple application, it might be easy. Or when your use case is very basic, then it might be easy. You just kind of embed the code to call the API, and now you are good in your kind of small application. But when you are developing an application in scale and you need to integrate now multiple APIs to your environment, and today, by the way, we'll be focusing on third-party APIs, but there is also an aspect of the internal APIs, but we'll focus on the third-party APIs consumption. You have a lot of challenges because now, let's say you integrate with an API from a bank that you need to integrate with, or payment API, travel API, and so on. And you need to write the code to actually integrate with these APIs. So you cannot write the code against the production API because you need to run through different cases, and you need to test the different use cases and so on. So working against the production API is not an option. Then what companies will do is to give you some sandbox that you will work with. Okay, so if you need to integrate with, let's say, a payment API or travel API, you might have a sandbox that you will be given by the third-party company. But now you run into a complete set of other challenges because the sandbox is sandbox. So it's not maintained by the company and it's not stable, and you need to integrate with multiple sandboxes, each one with its own API key and way of connecting. And because it's not maintained, we are speaking with customers that are telling us that every day they have another sandbox that is failing, and now they need to troubleshoot every day why they have problems in their CI/CD process and what is actually causing the failure. So a lot of instability that is happening because of that. And we had one customer that was it was kind of a large customer that was estimating that they are losing 9,000 developer days because of this problem of troubleshooting failures. Another aspect to take into account is that even if the sandbox is stable, you want to do stuff that is a bit more advanced. You want to maybe import your own data, okay, to the sandbox and test stuff with your own data. So we had a customer that was telling us that in order to do that, he was uploading, he needed to send like his own data to the company that is maintaining the sandbox. It took 3 weeks to upload the data, and then he got 2 days in order to test his integration with his own data. You can imagine the magnitude of block in that this development team faced. And there are a lot of other scenarios that we want to actually test things and develop against the sandbox that are not possible. So there are a lot of challenges that are caused when you are working in an API dependent environment that are not simple to solve.
Yeah, I'm actually jumping in, and the way that you started your answer, Ori, are completely relating to that. I mean, you said, Ido, that, okay, cool, I've done a project that integrated with an API. That's like step one, and congrats on that. But the problem when moving, from our perspective, when moving to production, is a problem of scale, because that simple integration, now as you're moving as a true company, not just as a side project, but as a true company, things begin to scale, meaning your API calls and your consumption scales over time. What is happening in real life is that as consumption scale, you begin to be bounded by the API provider. Like a known example will be rate limits. The provider will gonna bound you by a certain rate limits most of the time, and you need to comply with that rate limits unless you're not, and then you're getting that 49, too many requests. So the ability to maneuver the way that you're consuming in the boundaries of the API provider's rate limits is something that you need to take care of once you move into production. You didn't witness it once you were at the maybe like at the first phase or the development phase, but now at scale is something you need to think about. Another aspect to think about is the quota of the API provider. You got a quota that you need to understand how much am I consuming out of that quota. Am I going to finish my quota by the end of the month, depending on when is the quota is going to be renewal, and share that resource, which is a quota, among all of your consumers. You're talking about just one application, Ido, but think about multiple applications, maybe multiple services as you scale, once again, consuming the same API provider. So the problem of managing third-party APIs in production occurs at one point of time when you're going to hit scale and you're going to have multiple consumers and multiple API calls being made to providers. And this is the point where you need to think about active controls. You need to think about the proper way to rate limits from the client side. You need to think about maybe prioritizing calls so that the most important one will be sent out first to the API provider. You need to think about cost, which you haven't thought about when you integrated with the API in the first place, but it's going to hit you at the end of the month, that exceeding billing at the end of the month, if you're not keeping tracks and having truly metrics and measuring the performance and the actual cost of that API over time. So the problem, wrapping it all up, saying that it's one thing to integrate it with an API, but once you want to move to production and move into scale and over time, things will begin to break as they do. And then you need to think about the way to manage that consumption in a more proper and strategic manner.
Yeah, just one thing to add, maybe following what Eyal mentioned. So what I didn't mention before, what WireMock is actually doing. So WireMock basically gives you a platform that enables you to virtualize any API that you're depending on, and then create an isolated environment where you have full control on everything that is happening, and by that solving all the challenges that I mentioned and run much faster in the development process. So just an example, the rate limit that Eyal mentioned, we also see a lot of customers that are asking us, can you simulate rate limits in the simulation of the API? Because we want to see how our environment will behave when there are rate limits. So there is part of solving it in dev, which we do, and dev and test, and then there is the part where Eyal is solving it with Lunar.dev in production.
All right, but I will, and again, Ori, we can start from your part. So, I mean, I've looked at API mocks before. You know, I think a very simple strategy is you intercept, you know, the SDK or the fetch function that calls the API. You inject some statically coded responses. Maybe it's a JSON file or not, whatnot. You want to make it a little more interesting. You can randomize or select between a handful of different mocks that you have. Why is this? Why is mocking more complex than that? Why is it a product?
Yeah, good question. So basically, again, it's related to the question, do you need to do something very, very basic? And if you do need to do something very, very basic, then probably you can use like mocking, which is a feature of another product. There are a lot of products in the market that are kind of more lower cost or as a feature as a API management product that has mocking as well. But what they will do is mostly support basic use cases. Now, the thing is that you want to have a platform that will really enable you to simulate real-world scenarios in minimum maintenance, okay? And what does it mean? You want to really simulate production use cases and understand how your environment will behave that way, okay? And for that, you need a platform that really enable you to have flexibility in creating the mocks and have various ways to create mocks, either by recording traffic and generate the mocks from that, or by importing specs and generating mocks in that, to be able to do dynamic request match and dynamic response that really enable to simulate like various scenarios. We are running into a lot of customers that want to upload their own data and then create basically like by uploading your own data to a stub, which is kind of a subset of a mock, you can generate a lot of responses in one mock. Now, if you don't have this capability, it means that you need to create a lot of stubs, okay, each one for its own static response, which creates kind of a maintenance nightmare. So you want to have this flexibility in order to create that. We are speaking with a lot of customers that what they need to do is to integrate with banks. Okay, so as part of open banking agenda, a lot of banks needed now to expose their data through APIs. And what it means is that now they have very complex API that companies need to integrate with. But these APIs are not simple to integrate with. You have like a state that you need to save there when you are simulating these APIs. So there is a whole set of complex scenarios that is really, really not easy to simulate. And now you want to add to that also like abilities to test, for example, negative testing. Negative testing means I want to test how my application will behave when the API I call to is failing, or have delays. Okay, maybe it's a Black Friday and now my payment API will have delays and I want to see how my app will behave. So there is a really very large set of scenarios that you need to test in order to really make sure that your app behave in the right way when integrating with the API. And if you are trying to do that with a mocking that is very basic and static and doesn't give you a lot of flexibility, then you will not end up achieving the goals. And indeed, sometimes we go on calls with customers and they're saying, yeah, I tried mocking, but it didn't work for me and so on. And the answer that we are kind of saying is that you didn't use the right platform and use something that is very basic. So obviously it was very hard to get the value.
And I guess, yeah, I would kind of challenge you with a similar question. Where does, I mean, you know, I've seen rate limits before. There's some basic or, you know, maybe naive strategies for handling them, such as, you know, queuing requests or maybe just limiting on the client side. or just implementing some retries with exponential backoff. All of those are things that are available with pretty simple libraries for the client consuming the API. Where does that get more complicated?
Yeah, so it's a good question. And I think that the point where it gets more complicated and you need to think about a product is where basically it's not just good enough to have those implementations within your application. It's not just good enough to give the developer that is responsible for the integration to solve those things on its own within the application. And I'll explain. We can take a few scenarios where basically you understand that you need to have a focal point, kind of like what we call an API consumption gateway or a reverse API gateway that will be a centralized component that will look at the traffic and tunnel all the traffic via that gateway. One example is if you're having a distributed environment. So now you have multiple consumers, multiple services consuming the same API or even like multiple APIs. The way that you need to share the quota of that API provider among those services, let's say between staging and production, has to be a centralized place, has to be that one focal point where both staging and production will be tunneled via that gateway, and the allocation of quota will be distributed between them. So this is like one example where it's just not good enough to solve it from the application side. Another example is where you need to actually keep track on robust metrics and data collection on the API calls. For example, am I close to the rate limit? Or how much does it cost me to make those API calls? Or what is the performance of those APIs? It's one thing to integrate, as we said, with an API, but as you scale, you need to have that unified platform to see all of those APIs, the way they're interacting from your application itself, understanding the dependencies between services and the third-party APIs you're consuming, whether the problem is on your service or the third-party API. All those things call for a much more robust infrastructure than you need to build. The interesting thing is that we've been talking with our customers and also been basically obsessed with that idea for the past 2 years. We've seen companies at one point of time, as they scale, building it on their own. So they started exactly as you mentioned. They're gonna wrap it up in code. They're gonna do try and cache. They're gonna do some simple rate limiting. But over time, they understand that they need to dedicate a task force. Maybe it will be the platform team or the integration team to build that kind of a unified service. They can call it an egress service. They can call it a forward proxy or a reverse API gateway. But at one point in time, you need to have a centralized components to manage all of this traffic. This is where things begin to be much more complex, and you need to have a unified place to both visualize and gain visibility to all of the traffic and have proper controls over all of your distributed environment.
Cool. Now, pivoting here a little bit, I know obviously, AI, LLMs, that's been a lot of the hot topics for developers and in the tech industry in general over the last couple of years. It feels like every product now has some AI capability or AI featured backed by LLMs. And obviously the way that a lot of these LLM works, and I'm referring to models like GPT-4 by OpenAI or Claude by Anthropic, is they're exposed via APIs to developers. So obviously there is a lot of like LLM type APIs being integrated by developers into applications right now. Are, when you think about, both in the development and testing side, the mocking, but also thinking through rate limiting and quota management in production, are the challenges with LLM APIs the same, or are there any differences in how customers or developers should think about LLM APIs? And again, opening it to the both of you.
Yeah, maybe I will start again in the development stage. Basically, the way that we see that, we look at two directions in the working with AI and LLM APIs. First of all, is for developers that are using LLM APIs like OpenAI and ChatGPT. And they have the challenge that is very similar again to the API consumption challenges that we mentioned before, because eventually it's very similar challenges. You don't want to work necessarily with the production API. You we had customers that were complaining that were trying to use the LLM API in development and had a lot of delays. Okay, so every time they called it, there were delays, and then it impacted their ability to actually develop in an efficient way. So this is one direction. For that, by the way, we released a module a few months ago called Mock GPT that basically enable you to mock the OpenAI APIs. So this is one direction, which is very similar to all the other consumption of third-party APIs. And then the other direction is we do see that as more and more code will be generated automatically, plus agents that will be developed, the reliance and the consumption of APIs by this new set of API consumer will impact the market in that way, and will only kind of present more challenges in consumption of APIs in development environment.
Yeah, actually, it's interesting. We're seeing the same thing from our perspective, like the production side, about the risks that has to do with consuming AI, like LLM APIs, and also the AI agent buzz that is kicking in. What I want to add on top of it is, though everyone is talking about AI and AI agents, we've basically seen a very small portion of them actually moving to production at that point of time. I think that the reason is that there's still lack of controls to be moving with those capabilities to production. Those lack of controls will be associated with both reliability on those APIs and also cost. I mean, not reliability, more of governance and cost. So how do you make sure that those APIs, which can be extremely costly, you having proper controls? ChatGPT 4 can go to extreme amount of cost if you're not keeping track on. So you need to have those proper controls, like budget controls, in the way that you're consuming those APIs. And the currency of the cost is a bit different than other APIs, because the currency, as we know, is our tokens and not the volume of API calls. So you need to have another capability in place, which, by the way, Lunar presents with. It's the ability to look within the payload of an API call and tokenize the prompt, because only then you will understand how much does that API call weight or cost in the terms of tokens. That's a new challenge being opened up, and you need to understand how you can monitor it, have visibility over your usage of tokens, how does it correlate with cost, and how you actually budgeting it based on what you want to do. So this is like one challenge that is being imposed. And the other challenge that that Uri has mentioned is the next phase with AI, which is AI agents. Completely agreeing with you on that. This is something which basically us, Lunar.dev, and you, WireMock, has been talking about it like for a long time. There's a new consumer in town, and that consumer is an AI agent, which is an autonomous piece of code that connects with third-party APIs and make actions. And the same things applies here. I mean, how do you make sure that is having proper controls, that is not being met with those rate limits, is not exceeding with its costs, is not making API calls to third-party APIs that is not supposed to, leaking data outside that is not supposed to. The need to have a proper controls on AI agents is, I think, it's the main reason at that point of time that preventing most companies of actually moving that idea into production. So everyone is tinkering with the idea, but not moving as we can and as fast as we thought actually to production. Once again, lack of controls, mocking it, and then making sure that you have proper controls in the way that those AI agents or AI APIs are being consumed in production environment.
Very interesting. So obviously, with the rise of AI, a huge rise in a new kind of APIs being consumed, both traditional APIs being consumed by AI agents and new LLM APIs where tokens is the new currency. Super interesting stuff. I think what we're going to move on to next is, both maybe Uri first, kind of with the development and testing workflow, and then AI with production. Would love to see a quick demo of what these platforms look like in practice, just a couple of minutes to put some visuals behind a lot of what we've been talking about, and then maybe transition to some questions from the crowd. So for everyone watching at home, if you have any questions or any follow-ups you'd like to send to either Eyal or Uri, feel free to send them over in the Q&A section in Zoom. and I'll get working on those in a couple of minutes. So Ori, I'll turn it over to you first, and then we'll move on to Eyal.
Cool. So what I will I will show like really 5 minutes demo. And what I will do, I will actually focus on the third-party API consumption. And here I will give the example of PayPal Sandbox. Okay, so I'm a developer and I want to integrate PayPal with my environment because I need to activate payments through PayPal, which is obviously a very common use case. And PayPal, we talked about sandboxes, and a lot of companies will not even have sandboxes, okay? Or they will have sandboxes that will be very poorly maintained and will not be documented and so on. So PayPal obviously is an example of a company that invests a lot of effort in maintaining their sandbox, and they are considered very advanced sandbox. But even with that, there are challenges. So just to talk about some of the challenges, so I mentioned that one of the things can be instability of the sandbox. You see that yesterday I was kind of testing it, and I got an internal server error that occurred from the sandbox, okay? And I got several of those, okay? So now imagine that every day you are running that, and now every day you are getting errors, and it's kind of connected to your CI/CD process. It will create a lot of challenges. And this is an example, again, of a sandbox that is very maintained in a very great way. Other aspect, obviously, will be around like sophisticated negative testing. You want to do like chaos testing, load tests. You want to populate your own data, all the stuff that I mentioned before. So you cannot do it with the sandbox. Okay. So what I will show is how you use recording in order to create the virtualized service that represent PayPal APIs, and how do you use it later on. So this is WireMock. Okay. And basically, we have in WireMock Cloud, we have list of each of these is actually an API that we virtualize. And basically, I prepared here empty mock, okay, that we will use in order to record the traffic for PayPal API. Okay, so what I will do here, there are various ways to create new stubs. Okay, stub is actually a kind of a use case that we are simulating. Because there will be a lot of API calls and a lot of different use cases. And you can create API mocks by either importing open API specs, Swagger files, and so on. You can create mocks either by using the UI, using templates, and so on. What I will use today is record. Okay, so when you are recording traffic, basically what will happen here is that we are entering, one second, we are entering the target URL. Okay, here I'm entering the sandbox of PayPal. So basically what will happen here is that WireMock is a proxy in the middle. Okay, so all the traffic will be proxied now through WireMock. And WireMock will listen to the recording, to the traffic that is happening, and basically we'll record that and we'll generate the stubs from the recording. Okay, so I'm starting the recording, and now we'll use Postman for this example as an HTTP client, just to run several calls to the PayPal sandbox. And basically, you see we have the base URL here, and this is referring now to WireMock. So I will call list invoices. And I will call to show invoice details and maybe fully updated invoice. And again, like I will not go through all of that. Okay, and basically when I stop recording, what will happen is that basically WireMock created these stubs. And you can see in the definition, and again, we'll not show a full demo here, but in the definition of the stubs that were created, there are actually like two parts here: the request match, how the request will be matched, and then the response. Okay, and basically the response that is represented. And you can see in the match you have like related to what you asked before. Okay, why is it a product? You have a very sophisticated mechanism to match on query parameter, cookie, body, form parameters. You create like complex kind of conditions. You can import data sources like I mentioned. Imagine that you are simulating some contact database or contact API, and now you want to match by the specific contact ID. You can do stateful scenarios and more. And then in the response, again, what we see here, this is the response that was returned as part of the recording. Basically here it's static, but you have an ability to now take that and play from that and start to generate dynamic responses. So again, we'll not have time to kind of show the full scope of the dynamic responses, but basically, if we go to our documentation, you can do a lot of stuff around taking stuff from the request and putting in the response and string conditions, date and time, randomization. So you can do a lot of stuff that really enable you at the end of the day to generate realistic responses in minimum maintenance, because all of that will be on a very small number of stubs. And basically, at the end of the day, you call this URL. This is the URL that represents the mock. So from now on, you don't work anymore against PayPal Sandbox. Okay, from now on, you are working against WireMock, and when you are calling, you will get the response directly from WireMock Cloud. So what we did, again, we disconnected ourselves from the dependency on the sandbox or the API that we are working against that. And we are now able to work in an isolated environment where we have full control on everything that is happening, and we can simulate any scenario for our purpose of developing. And also the advantage is that when you are developing the code, all you need to do, you don't need to develop different code for testing and for production. It's the same code. The only thing that you need to do is change the URL here, that the base URL to WireMock Cloud. And once you move to production, you just change it to the real URL, and that's it. So you're able to navigate very, very quick. Maybe last thing that I will show, not related to necessarily the third-party API, but one more thing that WireMock is doing, and I should have shown that it's empty before, is that once you are creating a mock, and it doesn't matter if you create it from recording or from import and so on, we generate the open API spec for you. So basically, we have it's not only generation of mocks from open API spec, but we're also able to create the mocks, and from the mock generate the open API spec. We can generate a public documentation site that is documenting the various APIs. You can see here the different APIs that we actually generated. You have a mock server in there that you can call to, and so on. So one kind of aspect of that is to enable better parallel development, to enable documentation of APIs that you're actually working on. So this is an additional value that you are getting here. So again, in a nutshell, we showed how we are using recording in order to record the behavior of a sandbox environment and disconnect ourselves from this sandbox environment, and from now on work against the virtualized service that we created, and by that enable developers and testing team to move much faster in the development process, because now you have full control on everything and can simulate every scenario.
Very cool. Thanks for sharing that, Uri. And then, very briefly, Al, we'll hand it over to you to show some of the controls over once we actually move into production traffic, what that traffic shaping looks like with Lunar.
Okay. So as you said, not full demo, but just to show how it looks like in production and what you can do with it. So I'm gonna share my screen. As you can see, this is the control plane. So this is where you're seeing all of the traffic. This is like a simulation one, right? It's not a real traffic environment. This is our laboratory, but you can see a lot of traffic being consumed from multiple API providers. And if we'll drill down to one of those APIs and some of the metrics that we can see that, for example, we're consuming GitHub, the GitHub API, and all of the endpoints. When I'm going to dive deeper into it, we can see also the cost associated with the consumption of GitHub in real time and how many API calls I'm making. Interesting thing is that we can see that there's a rate limiting issue. There's an error that popped up because it surpassed a specific threshold. And if we want to, as we said, have proper controls on top of it, we want to do something active, then we can define what we called as a flow. In that example, if that's a problematic API, we'll go into flows. We'll select the flow that is a quota management, because I want to, in our example, divide the quota between staging and production to GitHub. So I'm gonna click on it, and as you can see, everything here is basically like a flow or a stream of actions you can make on your API calls from your service to your API provider. In our example, we're just gonna run over some of the controls. This is the client, this is the provider. We're gonna select, as we said, GitHub, and only control the traffic going to this endpoint, the problematic one.
Hey, Al, one request we do have from the audience, is there any way you can zoom in a little bit or make the screen a little smaller?
Because my screen is wide. Hold up. Let me reshare my screen. Just a sec. Believe that will solve the issue. Cool. So now it's better, I believe.
Yes. Yeah,
Awesome.
that's much better.
So control plane, all the third-party APIs you're consuming, we've seen GitHub, and we want to define a control in GitHub. What we want to show you is the definition of a quota management. In our example, I'm going to go to flows. I'm going to select the quota management flow. Basically, what it does is streaming all of the API calls being made from the client, that single client consuming GitHub, to the provider is going to be going through a queue where we're going to prioritize calls between staging and production environment. And then based on a filter, we're going to define some kind of a rate limiting, both for rate limiting for staging and a rate limiting for production. It's basically easy to do so. You just select in the API provider, GitHub. In that example, we're going to select that only the API calls for that specific endpoint will be filtered. That's actually something I've defined previously. And then we're going to define a queue. So you can see that in the queue limiter, you can define how many calls within that queue, what will be the TTL of that queue, and the filtering of calls being made either through staging or production. This is made by adding a header that depends on the customer. The customer can add that header on top of the API call. That header will be, in our example, X Lunar consumer tag. And we're going to define a priority, meaning that if the value of that header is production, that will give in a priority 1. If the header is staging, that will give a priority 2. And then basically filtering, right? We can define that, okay, if this is a production, if those API calls are made with the header of production, this is the limiter that I want to define, a prod limiter, and what you can see over here. And if it goes to staging, that this is the limiter. And everything can be pretty easily defined as a quota and sub-quotas. I want to define just that portion of that quota from GitHub to staging, and that portion to production. At the end of the day, because we're running out of time, it all comes down to the export of that file. This is a YAML file. That's the configuration. And that configuration will be uploaded to your self-hosted gateway and being run as a policy over there. Because we don't have enough time, then I've pre-recorded the way that it looks like from Grafana. And you can see that basically, if this is a staging and production environment, you can see that the traffic, after defining that policy and enforcing it, that flow, you can see the traffic actually change in real time, so that most of the allocation will go to production and to staging. Everything is configurable, controllable, and can be done just as a basic policy instead of actually writing it within your own code. So that's like just one representation of what you can do with the system. Same thing apply with API caching and rate limiting and all the things that we've talked about in this webinar. Yeah.
Cool. Well, thank you both for sharing that. That was great to see. Couple of questions that we have here that I would love to start digging into. First one that we have is question about rate limiting. Despite the risk of enabling bad actors, do we see future best practices dictating that API providers make their rate limits around calls more transparent?
Actually, we've seen an initiative from some industry leaders talking about the way to maybe standardize rate limiting. And I think this is one way of enforcing something from the API provider side. I will argue that the question is partially, I mean, you can do some kind of standardization from the provider side to make sure the rate limits will be better, and being based on the best practices of having the the responses being accurate and whatnot. But I'm saying that I think it's more on the client side to take control. So the API provider can take you up to a certain degree and making sure that it will be standardized. But at the end of the day, it's a resource. Those API providers, they're going to bound with those API ratings. And the question is, what you're going to do as the consumer of those APIs. So I do believe that even though we'll see additional initiatives trying to be enforced in the future of rate limiting, trying to be standardized and being better, at the end of the day, it depends on the active controls that you're going to enforce from your side to make sure that you're consuming, not to be bounded by the rate limits and all of those risks imposed by the API provider.
Perfect. Thanks, Eyal. One question that I have with WireMock is, I'm using WireMock OSS, open source software. Can you tell me what are the difference between the OSS and the cloud version?
Yeah, sure. So WireMock open source is widely used in the market, and we are the maintainers and the creators of WireMock open source, and we keep investing a lot of efforts in the open source. Having said that, there are differences between the open source and the cloud edition. The open source is you can download it. You need to install it in your environment. There is no user interface in order to create it. You need to create scripts or to write code in order to work with that. So much more technical in order to actually gain value from that, and more on the individual level. While WireMock Cloud is more, we position it as the developer productivity platform that will enable you to take the productivity in the organization to the next level. And some of the differences, it's first of all hosted in the cloud. We also have on-premise for that, but basically hosted in the cloud. It has a user interface that is very easy to use, like we saw, and enable also non-technical people to work with the product. We have today customers that are using it with hundreds of technical and non-technical people. Enterprise readiness features, team collaboration, a list of modules that exist in the commercial edition, in the cloud edition, and not in the open source, like chaos testing that enable you to simulate errors in a random way, stateful mocking that enable you to simulate like stateful scenarios in a very easy way, ability to import data, contract testing, and some other modules. So basically, like giving a lot more power and ability to scale the use of the virtualization across the company.
Cool. Going back to Lunar, I have one. So I'm kind of combining two questions here that seem kind of similar, but when deploying Lunar into production environment, what are the implications? This is where I recommend two questions, one around reliability and is there any uptime concern? And then a separate one around latency and what it looks like in terms of impact on request timing and latency.
Sure. And valid question. Once again, like we're a component in the middle of your API calls from your services to the API provider. This is something that all customers want to know. So Lunar is self-hosted. We're part of your, like the Lunar container is part of your cluster, and we're being benchmarking ourselves all the time. Worth mentioning that Lunar has been built on top of AJ proxy, which is like really high on performance. So the latency being added by Lunar is only up to 4 milliseconds in a P95, which is basically redundant. But then on top of it, in terms of reliability, Lunar in the paid version of it is not just one instance of a gateway, it's a cluster, a scalable cluster of gateways, which means that you're not being met with a single point of failure. If one Lunar gateway goes down, another one will be spun up, and you can load balance the traffic between the different gateways. They're sharing policies. The reason that it's been able to do so is because once you're having that cluster of gateways, they're having a shared state. This is already a shared state, which gives them the ability to actually, load balance and share the traffic between them. So that kind of give an answer to reliability. I'll add on top of it that we also have fail-safe mechanisms, which means that even if the gateway will go down, there's a fail-safe mechanism making sure that the API call will be made once again from the client to the API provider and not having any data loss.
Brilliant. I'll give kind of everyone in attendance one more opportunity to see if there's any other question or any other topics that we can kind of help chat through. Yeah, I think it seems like, yeah, I'm getting a couple of things. It seems like we have mostly got through the topics from the audience. This has been super interesting. Definitely feel like I have some more work to do now when the API I was integrating last night. Turns out it can be a bit more complicated than a single line of code.
Hold up, you're being modest, but we just really dive into the topic, and you didn't introduce yourself, so maybe worth saying.
Yeah.
But you've been moderating this event for the whole time.
Yeah, happy to. So hi everyone, I'm Ido. I've been your moderator. Been working, advising with Lunar and a handful of other companies in the API space over the last year. And previous to that, founded a company called Rapid API, so the world's largest API marketplace. Help millions of developers discover and connect to public API. So it's kind of funny, but I always joke that created a lot of the problems in the amount of API integrations that companies like WireMock and Lunar are now solving. So we made it in a lot of ways too easy to go and integrate APIs and made it so that now, I think it's great. A lot of applications are moving faster by relying on third-party APIs, but also made it necessary for tools like Lunar, WireMox, and other to come and, help think through those APIs kind of in T+1 or the day after integration.
Sweet. So Ido, thank you for having us and moderating. And Louis, it was great to see you, and thank you for the opportunity.
Yeah, thank you very much. It was fun.
Likewise, guys, this was a great event, and I appreciate you both joining.
Awesome.
Bye.